Today we're going to talk about absolute value and solving absolute value equations. First, let's talk about what absolute value actually means. The absolute value of a number is the distance between that number and 0 on a numbered line. So let's think about what we know about distance. If I look up my house on Google Maps and I see how far I am from school, and I told you I live -7 miles from school, does that make sense? Something sounds really off, doesn't it? So, that -7 doesn't sound right at all. Now, if I said I live 7 miles from school, that sounds a whole lot better. Distance is always a positive number. So let's try some of these. The absolute value of -3. To find this, I'm going to put a point at -3. I'm going to put a point at 0, and I'm going to count the units in between. 1, 2, 3. So the absolute value of -3 is 3. For the absolute value of 6, I put a point at 0 and at 6, and I count 1, 2, 3, 4, 5, 6, 6 units away. So the absolute value of 6 is 6. You may have seen absolute value before and notice that you're dropping off the negative. The reason we're doing that is simply because it is distance, and that makes it a positive number. So this is actually the reason why absolute value is always positive. So let's try solving some absolute value equations algebraically. First, let's look if the absolute value of x is 5. What can we find out about x? Absolute value is distance from 0. So if I start at 0 and I count to the right 5, 1, 2, 3, 4, 5. That lands me at +5. So that's a possible answer. I can also go to the left. 1, 2, 3, 4, 5, landing us at -5. So x could also be -5. So what's inside those absolute value brackets could be either +5 or -5. So our solution set would be the set of x's where x could be equal to a +5 or -5. And written like this is what we call set notation. Let's try another one. We're going to solve for x. So we see here the absolute value of 2x equals 20. Thinking back to our last example, when we had the absolute value of x was 5, and we counted both directions, we landed on +5 or -5. So if we're looking at 20 spaces away, we would either land on 20 or -20. So what's inside that absolute value bracket could be equal to 20, or it could also be equal to -20, and still give us 20 for our absolute value answer. So what we have to do is solve for both possibilities. So here I split this problem in two. I'm going to take that 2x and drop my absolute value bars. And I'm going to set it equal to 20. I'm also going to set it equal to -20 because we know it has to be equal to one of those two numbers. And then I'm going to solve them both. Let's start with 2x equals 20. I'm going to box in x just like I did before. Draw my line down for my equal sign. I see 2 times x. My inverse operation is division. So I'm going to divide both sides by 2. My 2's cancel on the left, which means I have x by itself. And on the right, 20 divided by 2 gives me 10. So that's one of my answer possibilities. Now, let's look at the one on the right here. 2x could be -20. So I'm just going to do the same thing. It's exactly the same steps, but I just start out with a different number on the right. So I still box in. I still draw my line down. I already figured out that to get rid of my 2 with 2x, I have to divide, so I do that on both sides. 2's cancel on the left. X comes down. It's by itself. On the right is the only place where this changes. -20 divided by 2 is a -10. So for this answer, x could be either a positive or -10. If we wrote that in set notation, it would look something like this. Let's try another one. It says solve for n. The absolute value of 5n equals negative 3. Well, is there anything that's a distance of negative 3 away from 0? Distance is positive. Absolute value is always positive, which means for this one there is no solution. Now, if you have a multiple choice problem, you might see other names for no solution. So no solution could also be known as a set with nothing in the middle. So you see our brackets with just a space inside. Or you see what looks like a circle with a line through it. Both of those indicate no solution, or the empty set that they call it. Let's try another one. Now for this one, I have to get the absolute value by itself first, because in order to know what that value is inside there, I have to have it by itself on the left. So what I do is I actually box in the whole absolute value, just like we boxed in for x, because we're really solving for that absolute value first. I see that I have a minus 7, so to get rid of it, I need to do plus 7 on both sides. My 7's cancel. On the right, 3 plus 7 is 10. Back on the left, that absolute value of 4x minus 8, that's going to be equal to 10. Now I know that 4x minus 8, what's inside that absolute value, it could be 10. It could also be negative 10. So here is where we split the problem out. And I have to set 4x minus 8 equal to 10. And I have to set 4x minus 8 equals to negative 10. And then solve. So let's start with the one on the left. I box in x, draw my line down. The furthest thing from x is minus 8. To get rid of it, I add plus 8 on both sides. It cancels out on the left. On the right, 10 plus 8 is 18. And 4x comes down on the right side. Now, 4x, 4 times x, I got to get rid of the 4. And the inverse is division. On both sides, same thing. My 4's cancel. 18 over 4 simplifies to 9 over 2. Let's look at the one on the right. Box in x. Draw my line down. I'm still doing exactly the same steps. You notice the only thing that's changing here out of all the stuff that we're doing is this number right here. So my right side's going to look different, but my left side's going to look the same. So here, minus 8, I need to do plus 8, both sides. 8's cancel. Now, on the right, negative 10 plus 8 is negative 2. On the left, same thing, 4x comes down. 4 times x, I got to undo that 4. I'm going to have to divide by 4, both sides. 4's cancel on the left, so that's x equals. And on the right, negative 2 over 4 is negative 1/2. So my solution could be either 9 over 2 or negative 1/2. We're going to pause right here to practice a little bit together, and then we're going to go into looking at some of the ones that are a little tougher and some options that we have.